In this video we are going to look at a fairly standard electric fields question that involves some resolving vectors. So pause the video now and try all parts of this question. Part A says determine the magnitude and direction of the electric field strength at the midpoint between the two charge field spheres. So the midpoint is obviously here. So the first thing we should really think about is what is the relationship between the electric field and the variables involved. So we're going to want to write down this equation, 1 over 4 pi epsilon naught q over r squared. And importantly, that is the electric field due to a charge. So we can work out the electric field due to B, do a second calculation for the electric field due to A. And also we need to realize the electric field is a vector field, so we can add the two separate fields to work out the overall field here. Now before we do that, we obviously need to work out exactly whether we're gonna, how we're gonna add them. We're gonna add them, or are we gonna subtract them? So it's probably actually useful to think about the direction first. So we've got a positive charge here, a negative charge here, and the electric field is defined as the way a positive charge moves. So if we put a positive test charge here, where is it going to move? Well, it's obviously going to be repelled by A, accelerated towards B. So the direction is going to be to the left, which means we're going to add the field because it feels the field from this one and it feels the field from this one. So now we can say that the electric field in the midpoint, let's put E mid, is going to be 1 over 4 pi epsilon naught. So let's do B first. So that's going to be 4 times 10 to the minus 9 coulombs over, we want the radius, which is the midpoint here, so 1.75 times 10 to the minus 2 meters squared, and then importantly plus the electric field from A, so 1 over 4 pi epsilon naught times by the charge on this one, so 5 times 10 to the minus 9 coulombs over, again, the same radius, which is the midpoint, so 1.75 times 10 to the minus 2, all squared. Epsilon naught is 8.85 times 10 to the minus 12. So I'm not going to type this into my calculator, I did do this one earlier. You should have had the electric field at the midpoint is equal to 1.17 plus 1.47 times 10 to the 5, which gives us overall 2.64 times 10 to the 5. Show that the electric force on A is 1.5 times 10 to the minus 4 newtons. So the electric force is given by 1 over 4 pi epsilon naught q over r squared, where we're looking at the separate charges. And importantly now, the radius is the full radius, the full distance between them, because we're looking at the force on A due to B. So it's the full distance between them and looking at the charges on each. So we can substitute in this charge, obviously with the conversion factors, and if you do that, you should end up with the force is 1.47 times 10 to the minus 4 newtons, which obviously rounds to 1.5 times 10 to the minus 4 newtons to one significant figure. Part C, using the method of resolving vectors or a vector triangle to determine the angle made by the string with the vertical. So what can we label on this one? Well, we know that there must be a force of its weight, and we know that there is this force due to the electric field this way, and we've got the tension here. So we've got 3 arrows, 3 forces, and it's an equilibrium. We've got a vector triangle. So what we can do is we can actually slide the arrows around and draw our triangle in a slightly different way to make a closed triangle, and then we can resolve the vectors that way. So what I'm going to do, I'm going to take this tension, I'm just going to slide it down this way, and then I'm going to take this electric force and I'm going to slide it down this way to create a closed vector triangle. So what I'm going to end up with is my weight going down, my electric force going left, and my tension going up, and importantly this angle here is exactly the same angle as we have in this diagram. If you're not entirely sure what I'm doing, I'm taking this electric force here and I'm just sliding it to the right, and then I'm taking the weight and I'm just moving it to close up the triangle here. So that's a slightly different way of explaining it. So now we know what these are. The electric force is 1.47 times 10 to the minus 4 newtons. The weight is 4.5 times 10 to the minus 5 kilograms times by the force of gravity. And we now have the opposite and the adjacent. So tan to the minus 1 of the opposite over the adjacent gives us theta, which gives us 18.4 degrees.